Good day, class! Welcome to our online class. It's me, Teacher Edzon, your teacher in this session. Okay, now, before we start, I would like to assure that you are already in your comfortable place so you can focus in our topic that we are going to discuss this day. So class, in checking our attendance, you just need to like this video so I can note that you already watched our lesson this day. So now, we have our objective. At the end of the lesson, you should be able to Number 1, explain why tectonic plates move. Number 2, discuss the different theories that explain plate movement. Number 3, relates the mechanism of continental drift and seafloor spreading to the movement of continents and ocean basin. And number 4, explain the plate tectonics theory and recognize the significance. Recall what you have learned in grade 8 since about the layers of the Earth. These are the crust, mantle, outer core, and inner core. The crust is the outer and tiniest layer which you can liken to an eggshell in terms of thickness relative to the other layers. Its surface is covered with soil and water. The crust is of two types, the continental and oceanic. The continental crust, which is thicker, is composed of low-density rocks, while the oceanic crust, which is thinner, consists of highly density rocks. Next, we have the mantle. Lies beneath the crust. It extends the most base of the crust to the core mantle boundary. The mantle is divided into upper and lower mantle. Next, we have the core. Extends from the core mantle boundary to the center of the Earth. It consists of an outer liquid core and an inner solid core. This layer is made of nickel-iron alloys. So now, let's proceed to this figure. We have the lithosphere. It is a solid outer part of the Earth. This layer includes the brittle uppermost portion of the mantle and crust, which is the outermost layer. It is the most rich of all the layers. Although the lithosphere is made of rocks that are ridges, they become elastic and ductile due to stress, temperature, and other curvature of the Earth. The lithosphere floats on the top of the highly viscous known as the asthenosphere. The asthenosphere has so much pressure and heat that the rock flows like a liquid. The lithosphere are also coolest among the Earth's layers. It is the ability to conduct heat from convection taking place in the plastic mantle below it. There are two types of lithosphere. We have the oceanic lithosphere and continental lithosphere. If we say oceanic lithosphere, it is a thinner and denser oceanic crust. And on the other hand, we have the continental lithosphere. It is a thicker and less dense continental crust. Now, let's proceed to plate tectonics. The lithosphere is the layer of the Earth that is mainly involved in the tectonic activities. This plate is divided into 7 major plates that include the African plate, the Antarctic plate, the Eurasian plate, Indo-Australian plate, North American plate, Pacific plate, and the South American plate. There are some minor plates that include the Caribbean, Scotia, Arabian, Indian, Philippine, Juan de Fuca, Cocos, and Nazca plates. These tectonic plates have the following characteristics which explain why the surface of the Earth is moving and why continents and ocean basins always undergo transformations. One plate carries both continental and oceanic crust. The average thickness of the lithosphere covered by a continental is about 125 km. The average thickness of the lithosphere covered by the oceanic crust is 75 km. Next, a plate floats on the asthenosphere, slide horizontally over it. It is a light block of ice that flows on a lake. It may be bent a little or maybe slightly move up and down. Each plate moves as a large solid rock. Next, tectonic plates move a very slow rate. Since the continents and the ocean make up the uppermost part of the lithosphere, both the continents and the oceanic crust move across the Earth simultaneously with the plates. Most of the tectonic activities take place at the boundaries of these plates. The movement of tectonic plate is made possible by the heat from the upper mantle. Heat makes the rock of the lithosphere more elastic. Tectonic activity is responsible for some of the Earth's most dramatic geologic events like earthquake, volcanoes, mountain buildings, and deep ocean trenches. All these formed are by tectonic activities in the lithosphere, which eventually shape the lithosphere itself. Now, let's proceed to the theories that explain plate movements. The changing positions of continents and ocean basins puzzled some scientists in the past. They knew that the continents and ocean basins move, but they could not explain how these move. In their search for an explanation of this phenomenon, the continental drift and seafloor expanding theories were conceived. Continental drift theory. In 1915, Alfred Wegener, a German scientist, published the continental drift, which states that the continents are moving. According to his theory, the Earth was once made of one large continent, this supercontinent called the Pangaea. Pangaea began to break up about 225 to 200 million years ago into smaller pieces that slowly drifted away from one another and moved their present positions. Scientists did not accept Wegener's theory of continental drift at that time. Wegener failed to present a mechanism that could explain how continents drift apart and what patterns they follow, if any. Wegener suggested that perhaps the rotation of Earth caused the continents to shift towards and apart from each other. Wegener's theory was rejected at that time. So these are the figures that explain Wegener's theory. So again, according to the theory of continental drift, the supercontinents fragmented into continents as we know as them today. So that's all for today. Hope you have learned something from it. See you in our next topic. Thank you.